Hello, y'all. This is Darrell Berry Jr. back continuing my review for my exam that is today in what, 3 hours, 4 hours, 4 hours. So I plan on continuing through the review. I'll focus on the things that I don't really understand as clearly. So these reviews won't be the most perfect explanations. Like for instance, the next one is the factoring of a matrix. What I'll do is use this most hated matrix from earlier. Now, I already have the solution of, let's see, factoring C equals AB. So I already have C from earlier. I'll use the same matrix that I've been using, which is this. I'll find the most neatly written one. This one looks all right. So I have this as my C, and 43, 46, 43, 57, 28, 53, 73, 34, 53. And we can see that it is a good matrix, so I just solved it. So I want to factor this into A and B. So if I remember right oh, let me share her up. Let's see here. There you go. So this is the same matrix that I solved earlier with the 4 different methods of multiplying matrices. So we already know two matrices A and B can be, which is the two things that I multiplied to get that. So we'll see if I get a different matrix from factoring or the same matrix, probably a different matrix. And then I'll put it in the calculator and confirm that it's the same. So my understanding is the first thing that we do some row operations. And man, it's going to be an ugly one to row operate. So why don't we do this? Just thinking about if I multiply this by something to make it all even, that might make it worse. But this is probably not the best one to practice on, but I'll still give it a shot. Actually, no, this is going to be too difficult with these difficult numbers. I want to make sure I have something that is doable in a reasonable amount of time. So I'm only going to make up a C. This is my C. So the first thing I'm going to do is do some row operations to try to get as much as I can pivots. And the pivots will let me know which columns of the original one to use. So I'll see my original one over here. So I'll have then I'll work from the mm, I'll do row 1 minus 4 row 3 row 1 and actually minus 3 row 3 and row 2 minus 2 row 3 is row 2. So let's see what we have. 4 minus 3 is 1. 8 minus 15, that's negative 7. And 6 minus 18, negative 12. Then we have minus 2, so 0, 0, negative 7, 1, 5, 6. Let me make sure I did that math correctly. Minus 3, minus 15, minus 12, and minus 18. And then minus 2, minus 10, minus 12. All right, that seems okay. So then we'll do row 3 minus row 1 to row 3. All right. 1, negative 7, negative 12, 0, 0, negative 7, and 0, 5 minus 7, 12, and 6 minus 12, 18. And I'm going to add plus row 3 plus 18 out of 7, row 2 to row 3. So that's going to give me 1, negative 7, negative 12, 0, 0, negative 7, 0, 12. And that's going to be 18 out of that 7 and it's negative. So that's 0. And now I can divide by 12, divide by negative 7. So that will give me 1, negative 7, negative 12. And I'll also move these rows around. So then that'll be 0, 1, 0, and 0, 0, 1. Okay. Well, maybe I did too much row reduction because obviously the same matrix by the identity matrix will give the same matrix. So what I'll do is just not row reduce completely, but I could make the identity matrix there. So the first row is the pivot, and then I have let me think. So I want to have something to multiply by that to get their original matrix. So that's going to give me their original matrix there. Then I'll say x1, x2, x3, y1, y2, y3 times this. Maybe I'll make it a bit easier and make this a row vector as well. I mean a pivot as well. So I have 1, 0, 0, 0, 1, 0, negative 12, 0, 1. So we know this is going to be the same as well as the original one. I would just have to figure out the last one. So the last column will be 4 negative 12 plus y1 equals 6 uh, negative 2 negative 12 plus y2 equals 5 and negative 12 plus y3 equals 6. So y3 equals 18, y1 equals 54, and y2 equals 29. So that means these two matrices should be my A and B, or one version of one. Just I decided to keep a few numbers uh, that are not, boom. So this should be A, this should be B. So I'm going to type these in and see what I get. See if it gives me the original matrix again that I made. Decimal in there. And that gave me 48, oh my gosh, 48102, 21053, and 15. Let's see if I typed something wrong. Hopefully I did. Let me see. Let's see what the issue would be. Work. So maybe I should do the full row operation, and I'm just mixing up my matrix multiplication here. So I'll do that. So we have, and I'll just do it the dot product way since, so I can go through it quickly. So I have 4 plus 0 plus 0, 2 plus 0 plus 0, 1 plus 0 plus 0, 0 plus 8 plus 0, 0 plus 10 plus 0, 0 plus 5 plus 0. That should give me my first column. And then I have next 48 plus 0 plus y1, negative 24 plus 0 plus y2, negative 12 plus 0 plus y3. So y1 minus 48 equals 6. So y1 equals 54. That's what I have. Oh my gosh. Forgot my negative on my 12. That's what I did. All right. Well, that gave me the right answer. Well then. No, I won't miss my negative on the exam. That one little negative sign threw everything off. So yes, y1 does equal 54. y2 does equal 20. Oh, well, let me just actually work it out since we already got it written. So y2 minus 24 equals 5, and y3 minus 12 equals 6. So y2 equals 29, y3 equals 18. So my B is 4854, 21029, 1518, and then my B is 10 negative 12, 0100001. So of course, if we completed the row operation, then I could have just left it as you know, could have just had the identity matrix, but that would make it too easy. So I'm pretty sure the problem that we have, we won't be able to row operation. So I'm sure we could actually, but I don't know. I guess we'll see. I should just happen to pick a matrix that I can row operation easily. All right, so let's go to the next one. So the next one is solving a system of equations. So I could do that really well. Then there's echelon and reduced echelon form. It's worth reviewing those definitions. Uh, so 7. So echelon form. So echelon form means that you have, naturally, let me look up the official definition. Right. So these are the definitions. Definition, echelon form. So let me share the book. And should be showing, but it's not. Let me see what's going on. as shown. Hmm. I'm not sure why it's not showing on this screen, but it should be. Maybe whatever was going wrong with that fixed it. Nope, it didn't. All right, for some reason they won't show there, but it'll show out here. So I'll just move it out here. All right, so definition. We call the first non-zero entry of a row its leading entry. The first non-zero entry of a row, reading left to right, is leading entry. And I think I might know what's causing the issue here. There we go. I think it was just the scale of the I know that sometimes I go to change something and like I go to change just the one item and like the scale of the whole thing changes sometimes. So still getting used to this program. All right. Yeah, I bet you that's what it was. All right, so here we go. So the leading entries move to the right in successive rows. So a matrix is an echelon form if the leading entries move to the right in successive rows. The entries of the column below each leading entry all zero. All the rows of zeros, all rows of zeros are at the bottom of the matrix. So if it's an echelon form, this number would be a leading entry. This number would be a leading entry. This number would be a leading entry. And I have to have zeros all along the bottom. So let's say I had 0, 0, 5, 6, 8, 0, 0, 0, 0, 2, 1, 3, 4, 5, 6. All right. So you notice not everything is a 1, but the leading entry to the, so this is the leading entry here, and the next leading entry is to the right in successive rows. So the successive row, even though I skipped the row, but it is to the right. Here, successive row zeros to the left, and all zeros are on the bottom. So the leading number of each row has zeros underneath it. All right. I am curious about if this was a non-zero here. the first one to be leading. However, well, I see. Then I would just do a row operation and move that row up. So if that was a number, I could swap rows 2 and 3, and then that would be the next leading one, and then the 3 would be the next leading one of the next row, and so forth. So that doesn't matter. Just make sure that you swap the rows around so that in as much successive order as you can, the next leading number has all zeros in front and below it, and all rows zero at the bottom. So this is echelon form. Reduced reduced echelon form. So in reduced echelon form, every leading entry is 1. All the entries of the column above the leading entry are 0 as well. So I'm not sure if that every leading entry is a 1. All the entries of the columns above each leading entry are 1 as well. So these would all be 1s. And these would have to all be 0s. And I wonder about, so this one fits the definition. Leading entry, 1s and all 0s. This one fits the definition. This one fits the definition. I wonder if the other rows, I mean, technically it fits the definition. This one is not a leading uh, uh, number because the one is to the left, so that doesn't matter. This is not a leading number. This is not. This is not. So that should actually technically be. Oh, I'm looking at the wrong. Oh, reduced echelon form. So actually swap these mistake. So this should be it. But I'm not sure about the other numbers, but it does fit the definition. If a matrix is an echelon form, we call the leading entry of any non-zero row a pivot. We refer to the columns in which the pivot appears a pivot column, and to the corresponding variables in the original system of equations as pivot variables. The remaining variables are called free variables. Right? So this is a pivot, pivot, pivot. The leading entry of a non-zero, of any non-zero row is a pivot. So pivots go by row. I was thinking columns. But that makes sense because that row, each row is an equation. The columns in which the pivot appears is a pivot column. And the variables are pivot variables. For instance, x1, x3, and x4. So x2 is a free variable, and so on and so forth. So it says, what did we learn from, and how is the book showing? I think I must have zoomed in more yesterday, or zoomed in less. Let's see here. That's better. Right? What do we learn from the respective augmented matrices of our early examples? So the augmented matrices means you have A and B with a line in the middle of them. So this would be an augmented matrix. Use a symbolism, the symbol for it, augmented. The augmented matrices from example 3, A is in reduced echelon form. Okay, so you can have other numbers. So that means that these columns don't stop it from being reduced, long as long as the leading entry of any row is the leading entry in any row is a 1 and is the only number that's not 0 in that column. That's another way to put it. The leading entry here is a 1, and that 1 is the only non-zero number in that column. Doesn't matter what else happens on any of the other rows or later in that same row. B is an echelon form because it has a leading pivot that's a 1, but there's a 1 in front that. So therefore, that's what makes it not reduced. This was a 0, it will be reduced. And C is neither because the leading number is not a success of rows. This 1 doesn't have a 0 underneath it, and the pivot here is not a 1. So, okay, it's easy enough. All right. So I'll take a break here, and we'll continue from the next section of the review after I'm back.